Good evening. Good evening and welcome to NASA Robotic Servicing. This program is sponsored by NASA and the Maryland STEM Festival and hosted by Carroll County Public Library with support from the Maryland State Library. We're delighted that you're joining us this evening. Before I introduce our special guests, I'd like to introduce the library team. I'm Dorothy Stoltz with Carroll County Public Library. I'm Director for Community Engagement. I also am serving as the board president for the Maryland STEM Festival. And we have tonight Amber Farron, who is our communications specialist with the library. And she'll be our tech production person, and she and I will be monitoring the Q&A. So speaking of Q&A, if you're joining us by Zoom, please use the Q&A portal to type your questions and comments. And you can find that by hovering your cursor at the bottom of the Zoom screen, and you'll see the Q&A icon. And you can click on that, a screen will pop up, type in your question, your comment. If you're joining us by Facebook, please use the chat box. The recording for tonight's program will be posted to the Carroll County Public Library YouTube page, and we encourage you to go there to watch it again or share it with friends and family. So we are delighted that NASA is sponsoring this, and I want to give a very special shout out to NASA Goddard Space Flight Center as our special sponsor. We also have the Maryland STEM Festival as a sponsor. And I believe that the executive director is here this evening, Phil Rogofsky. Phil, do you want to turn on your mic and video and say a few words?
I can't turn on the video. I think you're controlling that, but I can certainly say a few things. Yes, so we're looking forward to this event. NASA has been very supportive of the festival this year. I think close to 20 events have been sponsored or run by NASA, and we have a very big one coming up next Wednesday at 4 p.m. We'll have a meeting with astronaut Ricky Arnold, who is a Maryland native. So please check that out and enjoy this program and all of the other great programs that NASA is putting on the rest of the festival, as well as the other hosts. Thank you, Dorothy.
Yeah, sorry about the video glitch, but thank you so much for joining us, Phil. And I do want to say that this year, with it being all virtual, Phil has just gone all out, and we have a virtual parade, we have comedy shows, we have concerts, in addition to all kinds of wonderful activities like the one tonight. So many, many thanks, Phil. The Carroll County Public Library is really honored to be hosting tonight's program. We have support from the Maryland State Library, but we also have 13 library systems from across the state that are co-hosting, and we want to give them a special shout out. So it includes library systems from Allegheny County, Anne Arundel, Calvert, Caroline, Cecil, Harford, Howard, Kent, Prince George's, Queen Anne's, Somerset, Washington, and Wicomico. So thank you so much for your support in promoting tonight's program. So now I'd like to introduce Dr. Billy Gallagher, who is a NASA Senior Robotic Systems Engineer, and Dr. Matthew Marcus, who is a NASA Space Systems and Robotics Engineer. So let's please give a warm welcome to Billy and Matt. Sorry.
Thank you, Dorothy. I'm happy to be here. I think that it's always exciting to kind of get to talk to people, and I hope that we can answer as many questions as we can tonight. You want me to go ahead and share my side of the presentation?
Sounds good to me.
Okay. How are we looking there?
Looks great.
Okay. So to start with, I think, Matt, we can introduce ourselves. Like Dorothy said, my name is Billy Gallagher. I have a background in aerospace engineering and robotics. I went to University of Notre Dame for my undergraduate studies, and then I went to Georgia Institute of Technology for my graduate studies. I've been with Goddard Space Flight Center for going on about 8 years now. Before that, I actually did a couple stints as an intern, both at Goddard Space Flight Center and at the Jet Propulsion Lab out in California. And my focus is on the design and control of robotic systems. Specifically, I have a background in both human-robot interaction, so how people interact with robots that they see in person. You walk up to a robot and how you both physically and emotionally interact with it, as well as some of the remote robotic control aspects of how we would control robots in space.
And my name is Matthew Marcus. I also have a PhD in aerospace engineering. I did both my bachelor's degree and PhD at the University of Maryland. Yeah, I have a background, like I said, in aerospace engineering and robotics and sort of space mission design. So my research background is more on the mission design and spacecraft design than Billy's, which is more on the robotics side. My work has largely focused on design of satellite servicing and orbital debris removal missions, as well as some studies of small bodies missions for basically scientific asteroid missions and deflection of harmful asteroids that may be approaching the Earth.
So just now that you know a little bit about us, to give you some insight into where we work at NASA's Exploration and In-Space Services Division at NASA Goddard Space Flight Center. NExIS, as we like to call it, because NASA loves acronyms. You will hear lots of acronyms tonight. We will do our best to explain all of the acronyms, but if we miss something, please feel free to ask us a question, let us know, what we missed, and we'll be happy to explain it. NExIS is a group at Goddard that has been around for several years now. Over the course of time, it's evolved from a small group of people working with one robot in the corner of a lab to we now have a couple hundred people working on several missions and several dozen robots spread across the country. We focus primarily on doing the research and technology development that's needed to advance the state of the art of on-orbit servicing and refueling, as well as exploring. Matt said asteroids, small bodies. We've done some mission studies to go to asteroids, to go to comets. One of our missions is currently working with JPL to do Mars sample return. So that's getting pieces of Mars from the rovers that are on Mars now and actually bringing them back to Earth. And so you can see just scrolling through some of the pictures, and we'll get into some of that a bit more. Matt, do you have anything you want to add?
I think that pretty much covers it.
Okay. So to start with, I thought we'd give you just a quick overview of our facilities. So what you see here will just be kind of a brief, whirlwind tour of the labs at Goddard. And it shows you where we are and what we're going to do, and then we'll go and talk about each of those in detail in a little bit. But we thought that we might start with a series that we call Pass the Torque. And Katie Caudry, our wonderful outreach and coordinator that's actually helped us to be here with you all tonight, has put together this series and has done an amazing job about what goes on in the world of robotic satellite servicing. So we'll start with that. It's just a 15-minute video, and it highlights one of the other robotic operators in our group. Her name is Zakia Tomlinson. We work with her on a daily basis, and she's really good at doing a lot of the outreach events and giving tours and really explaining what it is we do. So we thought we'd start with that. And then once we do that, we'll go into more details, and feel free to ask questions along the way. We're happy to stop and ask questions and answer questions while we go. We really want you to learn what you want to learn. And if there's something that interests you, please let us know. So enjoy the video, and then we'll be back with you shortly.
Hello, and welcome back to Pass the Torque. I'm your host, Katie Cadre. So far this season, we've heard about on-orbit servicing, assembly, and manufacturing, or OSAM technologies. Today, we're going to hear about robotics from robotics engineer Zakia Tomlinson. Don't forget, you can drop any questions you have for Zakia in the comments below for a chance to have them answered later this week. Let's go ahead and get started with question 1. What does a day in the life of a robotics engineer look like?
One of my favorite things about my job is that no day is the same. I might spend one day using our robots in our lab to test out a new tool or task. I could spend another day in meetings going over plans for how we're going to run our mission, or spend the time writing reports about how our last test went. I could spend a day training other engineers on how to safely operate the robots, or working with our interns to help them with their tasks. So I really enjoy the variety that comes from the job. So I really enjoy actually getting to do testing with the robots. I really enjoy the experimentation, trying to figure out how something's supposed to work, overcoming problems is really the most fun part of the job.
Can you tell us about your background?
So I actually started my engineering education while I was still in high school. I attended a magnet program in Howard County, Maryland. After that, I got my bachelor's degree in aerospace engineering from the University of Maryland, College Park, and a master's in aeronautics and astronautics from MIT. I actually haven't worked anywhere other than at NASA. I started as an intern when I was still in college at Kennedy Space Center. I worked in testing experiment racks that were going to the International Space Station. And after I finished my master's degree, I spent 2 years at Johnson Space Center in Houston as a robotic instructor for the International Space Station program. I really enjoyed the experience of being able to teach classes and work with the astronaut candidates and the crew of the second-to-last shuttle mission, STS-134. After I left Texas, I moved up to Maryland, and I've been working at Goddard Space Flight Center for the last 9 years.
How are robotics applied differently on Earth and in space? How can robotics enable further space exploration?
A lot of robotic systems that are on Earth are used for tasks that are either requiring a lot of repetitive actions or a high degree of precision, things like putting together cars or other machinery. Both on the ground, though, and in space, robots can be used in environments that it's too difficult or too dangerous for humans to go. So on the ground, that can be things like exploring underground, or things where there may be things like explosives. In space, robots don't get tired, they don't need food, so they can be able to move large objects, they can stay out and keep working beyond when humans would need to go inside to get rest or to get more air, oxygen for their spacesuits and things like that. So they are able to provide support for a lot of tasks in space that alongside people or doing tasks instead of people. One of the other things that in space, robots are able to go to places that we can't send humans safely yet, other planets or other bodies in our solar system. So that allows us to gain more knowledge about what else is going on in our solar system even earlier than when we'd be able to send people there.
What are some challenges of using robots in space? What can robots do in space that humans can't, and vice versa?
There are a lot of different things that robots can do in space, from constructing large structures down to picking up tools or setting up an environment so that an astronaut could work with it later. The robots are really great for the larger tasks, especially. There's things that are too big for humans to lift. One of the challenges, though, when you get down to some of the smaller tasks, is that it's much more difficult for robots to sense their environment like a human does. The human hand is a really amazing instrument, and so once you're trying to get a robot to emulate that, it's a very difficult thing to do. You need sensors to be able to determine how hard are you pushing on something. You don't want to crush it by accident. You need to be going more slowly so that you can stop when you start seeing cues that the robot is doing something that you may not want it to do. So it can often take more time for a robot to do a task than a human could, but at the same time, they could also be performing that tasks, let's say while the crew is asleep, and that's going to help your schedule because you'll be further ahead in the morning than if you were waiting for the crew.
Can you tell us about how robotics will be used in the OSAM-1 mission?
Robots during the OSAM-1 mission will be used to service a science satellite that's already in space, as well as demonstrate manufacturing and assembly capabilities in space. Right now, if a satellite is running out of fuel towards the end of its mission, a lot of times the instruments are still functioning, and so it could still continue to give us really great scientific discoveries if it had more fuel. And so that's what our point of the mission is, to allow this satellite to continue operating for a longer period of time based on what a robot can do to help out with refueling. Once we've done that, we'll also be demonstrating for the future, and hoping to expand our capabilities of what robots can do for assembly. Right now, we're limited in kind of how big structures in space can be by what can fit onto a rocket. And so if we can use robots to assemble pieces together once we get into space, that'll allow us to build new structures for new purposes and improve the missions that we can do in the future. The humans on the ground will be able to watch what's happening on the spacecraft through cameras and then send commands to the robots to be able to grab onto the science satellite, in the first place, bring the two satellites together, and then get access to the fuel valves using various different tools that we'll need to cut through the outer protective blanketing, remove caps that are on the spacecraft so that you can actually get to the fuel valves, and then pump fuel into the spacecraft and cover everything up once you're done so that the spacecraft can then continue on its way and continue its mission. The main reason we don't want to use the joysticks in space is because it's harder. You can't verify what your commands are. It's kind of just an instant, you've sent an input and the robot would respond to that, versus the commands that you can type into the screen. Someone else can lay eyes on that and verify that that's actually what you want to send to the spacecraft before the robot acts on that input. There's a several second delay between when we would send the command on the ground and when the robot would respond, based on as kind of that signal bouncing through different ground stations and then up to satellites to space. So that also makes it less desirable that you would be inputting things by joysticks, because you want to be able to verify everything, because you won't see the robot start moving instantaneously because of the delay. So if it was doing a wrong command, it would already be moving by the time you knew that, to then be able to stop it.
How else is NASA using robots?
So a couple examples of how else NASA uses robots are the International Space Station and Mars rovers. The space station actually could not have been constructed if it weren't for the robotic arm that it has on board that was used to lift and install many of the modules that are on the station. And right now, the arms still get used for being able to do maintenance tasks, repairs, docking cargo spacecraft that come up, and also conducting experiments on the station. On the Mars rovers, they have robotic arms that are used to collect and analyze samples as they're traveling, so you can learn more about the rocks, the dirt, and the area that they're moving through. I guess the largest difference between different robot systems, whether it's for OSAM or on the space station or on Mars, is the sizes between them. But different robots can have different numbers or different types of joints, and that will affect their ability for how they move. Especially for, let's say, the Mars rovers and a lot of smaller arms, they'll have joints so that they can move very similarly to a human arm with a shoulder, elbow, and wrist. One of the unique things with the arm on the International Space Station is that its wrist can become its shoulder and vice versa. So either end of the robot can attach onto a structure and become the shoulder, and the other end can be out grabbing other objects like the hand or the wrist of the robot. And so that allows it to travel around the station and work in different areas without the robot having to be even larger than it already is.
What are you most looking forward to at NASA?
So every year, both during the summer and the school year, we have several interns that work with our group. Some of them are in high school, some of them are in college, some are focused on mechanical design, and some working on software. But this summer is my 5th year of working with and coordinating our interns. And every year I look forward to the new students that come in and the things that they're going to discover both through their work and about themselves. It's really amazing when they find new interests that they didn't know that they had, or if someone confirms the fact that the career they always thought they wanted really is what they want to do with their lives. So I always look forward to working with them every year and finding new students to work with us in the future.
What is your favorite memory from your time as a robotics engineer?
My favorite memory from my time here as a robotics engineer was working on a test campaign at a facility up in Canada. The robotic arm that's used on the International Space Station was designed by the Canadians, and they have a facility there that has almost the same hardware and software as what's on the station. And so we were using this to be able to test out an experiment that we were going to run on the space station. And it was a lot of work leading up to that to get ready, and a lot of long hours when we were there, but it was a fantastic opportunity to learn from other people doing similar things that we're doing, share our techniques and our knowledge that we've gained over time together. It was just a really great learning opportunity to help us hopefully make our own mission better and from the knowledge that we got.
How did you first become interested in robotics?
During my senior year of high school, my teacher entered my class into a robotics competition called BotBall. It's a lot like FIRST Robotics. That was my first exposure really to robotics or to programming, and I really enjoyed both. I didn't think of it at the time as a career that I might get into, but kind of that opportunity led to other opportunities, which led to other opportunities along the way. So I'm really glad that I gave it a chance to something new when I was in high school, because it's shaped my life ever since.
What advice do you have for people who want to get involved in robotics?
There are a lot of different aspects to robotics, whether you like programming or you like design, you like to do testing. So I guess my best advice, if you think this is something that you would be interested in, is to find a way through clubs or your classes in school or research opportunities to get involved and try a bunch of different things and see what you really like, so you can hopefully find some aspect that you really love and continue working in that.
What do you like to do for fun?
My greatest love, other than space, is traveling. When I was in college, I was lucky enough to spend a summer doing study abroad in Europe and living on a ship. That really started a deep love of seeing new places and getting to experience and learn about new cultures. I've gone to almost 30 states and 35 countries around the world so far, and hopefully someday I'll be able to say that I've been to all 7 continents. I equally love going to places that are beautiful just for nature, like mountains in Alaska or coral reefs, scuba diving in the Caribbean, as well as going to big cities and famous landmarks like New Orleans or Paris. Really, I love everything about traveling, from all the time you spend planning and anticipating, even the time that you have to spend packing, and of course, actually enjoying the adventure while you're there.
Thanks so much, Zakia. And thank you for tuning in to another episode of Pass the Torque. Don't forget, if you have any questions for Zakia, you can drop them in the comments below for a chance to have them answered later this week. Be sure to check back here next week for another brand new episode of Pass the Torque. See you then.
All right, for a little bit of show and tell, one of my other interests is sports. Football, hockey, and racing are my favorites, and I collect different items from the different teams and races that I've been able to go see in person. So some of my favorites here relate to the championship that my local teams have won. So the football in the back is from the Ravens. I have 2 hockey pucks for the Capitals, including for their win in the Stanley Cup. And I also have a ball for the Nationals. And I also have newspaper covers from when each of them won, which was really exciting and a lot of fun to watch those games. For racing, I started collecting cars for the different drivers that I follow. I really am fascinated by the technology that goes into racing. It kind of like this technology that goes into spaceflight, but it's a lot of fun to learn about. And every year I look forward to May to be able to go to Indianapolis and see the cars at the Indianapolis Motor Speedway. There's really nothing like seeing a car go 230 miles.
So I hope that you enjoyed hearing from Zakia and learning a bit about what we do at Goddard. Before we move on to any other things, Amber and Dorothy, do you want to take any questions?
Yes, we do have a couple of questions if you're ready.
Sure.
Sarah is saying, first of all, just thanks so much for doing this. And she was asking how many people are doing this. And I think she's meaning how many people at NASA working in robotics.
So we have, I honestly don't know that I could tell you the answer to that question because there is robotics everywhere at NASA. As you saw Zakia mention, there's the Mars rovers out at JPL out in California. There's us at Goddard. We have, Matt, what would you say, a couple hundred people?
I think so. If you include like, so we have, a robotics group, but then we have a whole team that's even bigger than that. That's working on OSAM-1 on this, upcoming refueling mission that we're working on. So I'd say between the two of those, it's probably at least, like 200 or 300 at Goddard.
Yeah. And then there's also teams at Langley Research Center down in Virginia. And there's a bunch of robotics going on at Johnson Space Center, JSC in Houston as well. So I would say that there's quite a few, many people. I don't know that I can give you a number.
At least 1,000 across NASA and JPL.
Yeah, that sounds about right.
That's great. Yeah. Now, Jackson is asking a couple of questions. One is, how does a satellite work? And then also, how easy is it to program robots? And then how does Robonaut 2 work?
Matt, you want to take the satellite question? I think that's more up your knowledge base.
Sure. So yeah, satellite is basically anything that orbits the Earth you can consider a satellite. But normally, when we're talking about satellites, we're normally talking about some sort of machine that we've launched that orbits the Earth. So basically, any satellite is a platform that has some sort of instrument on it that usually, like when it comes down to it, is like a highly specialized camera. And the satellite is basically everything you need to operate that camera and to get data from it back down to the ground. So you need, electrical power, both to power the camera itself and to power antennas on the spacecraft that will transmit that data. You need usually a propulsion system, so some sort of rocket engines to keep it pointed in the right direction and move it around in orbit. You need, computers to run all this. Usually, with the exception of basically the International Space Station and things going to it, all the satellites that we have in orbit operate, autonomously to some degree, or sort of on their own, robotically. So that's basically how a satellite works. Is it's taking some sort of data. And it has, all of these different pieces that have to come together to get that down to the Earth.
That's great. Thank you.
And then the other half of that question about programming robotics, there are a range of answers to that question, really. There are some great robot kits. Lego makes some great robotics kits, and there's some great things that you'll find in local stores, anywhere from toy stores, Target, Walmart, on Amazon, that you can find that are really good for learning to program robots. And those kinds of robots actually are surprisingly easy to program, because you can put them together yourself. You can plug them into your own computer at home. Some of them even have phone apps, so you can connect to them over Bluetooth. And you can make really fun, simple programs to drive your robots around the house. And then once you get the hang of those, you can work your way up to bigger and bigger robots. Eventually you get to the kind like you can see behind me here. This is the kind of industrial robot that we use at Goddard for testing hardware. And okay, apparently my video is not showing up at the moment, so I apologize. But the kind of robots that you'll see in a second, let me pull up. Here we go. So you can see this robot arm here on the screen. And these robots are actually a lot more complicated to program because they have a lot more sensors. They're a lot more capable. So we have a whole team of people that is designing the software that runs these robots. And the same is going to be true for Robonaut. For those that aren't familiar, Robonaut is basically a robotic astronaut looking machine that is on the International Space Station. And he has a helmet and two arms, and it can travel around the outside of the International Space Station. And it is controlled either from mission control in Houston or by the astronauts in the space station, usually with a computer that is dedicated to it and probably has some joysticks and some keyboard commands and things to make Robonaut do what they need it to do. So really, there's some really easy robots out there that you can tinker with and go play with right now. And then eventually the bigger robots, once you get the hang of it, they all work the same. It's just a matter of size and complexity.
And Matt and Billy, I'd like to just interject for the students in tonight's program many of you probably use your local library, but if you check out the activities there, libraries are increasingly offering coding programs, robotics type programs. We do have the Lego robotics Legos. And so we're trying to offer more in a informal type setting for kids to try out. And I'll say that Carroll County Library, we're very fortunate to have a Pepper robot, a humanoid robot that's about 4 foot tall. And we have a team that takes Pepper around to do some coding and learn to work with that type of robot. So check out your local library too. Well, let's go on to some questions here. We have, let's take a couple more. Andre is asking, how do the satellites make a signal? And is there a person that controls the rover's movement, or is it automatic and you only control pictures?
So I guess the satellites, basically just like your cell phone, have an antenna on them that makes the signal. And like in some cases, especially with a lot of newer, smaller satellites, it's like literally the same antennas that they put in cell phones. They use the same technology on the satellites. With the Mars rovers, that it's sort of a combination of the two, sort of that, the beginning of, it's called the Sol, is what we call a day on Mars. They will, sort of send like a path for, where they want the robot to move, or sort of what measurements they want it to take for that entire day. And then the robot has some autonomy, some level of artificial intelligence on board that says, okay, if I need to move, 500 feet ahead of me, how do I get there, avoiding any rocks or other obstacles that may be in my way?
It's great. Thank you. Let's take one more question right now. How would I be able, this is coming from Quinny, how would I be able to get an internship with NASA? I am in 7th grade and I would like to get involved as early as I can.
So Quinny, thank you very much for asking. We, as you saw in the video, Zakia talked about one of her roles is actually managing our interns. And if you go to NASA's website and you go to, I believe it's interns.nasa.gov, there's a whole bunch of information there. We generally, in our group at least, start taking interns as early as high school. And so there's all kinds of opportunities. There's also, even before you get to internships, NASA runs a whole bunch of programs that are geared towards students of any age. So you can usually find something of interest that's right for you. And then when we start taking high school interns, in our group at least, we try and find really interesting projects for them to work on so that they get to learn the ropes of what it means to do robotics, what it means to work on spacecraft. And it's amazing sometimes how ingenious some of these intern projects turn out to be, and the way that we've been able to incorporate those intern projects into what's going to actually fly in space. So there's all kinds of opportunities out there. And you can definitely find anything you want to do at NASA's website, interns.nasa.gov.
Great, thank you. And Zahara and Tele are saying yes, big thank you. So do you want to continue? Do you want to continue with your presentation a little bit, and then we'll go back to some more questions?
Sure. So if we go back to this video, so you saw some of this and what Zakia was talking about. This is basically a video of what the main mission that Matt and I are working on is going to look like. So you can see the robotic arm here, and it's going to go up, it's going to go mate with, and by mate with, we mean go find and grab onto a satellite that's in orbit that is low on fuel. Specifically, we're talking about a satellite called Landsat 7. So if you ever go look at weather imagery, so if you look at pictures of the ground from space, those all come from a satellite like Landsat 7. And so the robot here you see is going to have a special gripper on the end, and a gripper basically just has two little claws that can reach out and grab onto the bottom of this satellite. And once it's grabbed onto the bottom of the satellite, it will then pull the satellite down and lock it in place. And so basically we've taken our two satellites, one with the robot arm and one that needs to be refueled, and locked them together so that they now work together. Then we need to go in and we have a whole bunch of tools that we've designed that go on the end of the robot to open up that satellite. When you put a satellite in space, it's always going to be covered in a protective layer. And that protective layer keeps dust and debris as well as sunlight out of the internals of the satellite, so it's protected. So the first thing we need to go in is remove that protective layer, and then underneath that, there are a series of valves. You can think of a valve just like a gas tank on your car. You go to the gas station and you open the gas tank door, and you have to put a nozzle in, and that nozzle fills the gas tank with gas. So what you see here, this is removing that gas cap. It may look a little bit different, but underneath it, it's got a place for you to put gas. So then we take our robot and we go grab a special tool that's designed specifically for refueling. You can see the hose attached to it there. And that hose goes into our satellite that we've built, which is basically a large gas tank. Once we put that hose and that refueling tool up to the nozzle on the satellite that we're refueling, we can connect to it. You can see it doing a bunch of work here to make sure it's connected, and then we can flow some fuel into the fuel tanks. And one of the big questions we get is, what kind of fuel do these satellites use? And there's many answers to that question. The one that we're talking about uses a special kind of fuel called a hypergolic fuel. It's a very fancy fuel. It's very toxic to people, but it's very effective for spacecraft fuel. There are other spacecraft that use fuel that's much more similar to what you put in your car. It's basically a gas that burns. And then there's other fuels that use what you would see in the big rockets, which is hydrogen and oxygen. And if anybody has any chemistry experience, you know that when you put hydrogen and oxygen together, you get water. That's the main thing that water is made of. And so that is what's done in some satellites. They put the hydrogen and oxygen together, you get water, and you spray water out the end of the nozzle like a hose, and that pushes your satellite around. So that's the first half of the mission that Zakiya was mentioning, which is called OSAM-1 for on-orbit servicing and manufacturing. The second half is the manufacturing part of this, which basically is going to, once we leave the spacecraft that we've serviced, is going to use a different robot arm to assemble a bunch of pieces into an antenna. So as Matt was saying before, how we get the signals back down to Earth, we use an antenna. It's just much bigger than the kind that's in your cell phone. And then it's going to test that antenna. And then it's also going to run another experiment that we call MakerSat, which is basically going to make beams. So if you've ever seen the inside of a wall of your house, you know that there are beams there. If you've ever seen a construction site of a new building going up, you can see the large beams that they put in place to support the building. Spacecraft do the same thing. You can see the solar panels on the side of the spacecraft are supported by large beams. If we can assemble these things in space, if we can make these beams in space, we can make bigger satellites than what we can launch on a rocket. An example of that is the International Space Station was launched in a bunch of pieces. If we want to go further than the International Space Station, go back to the moon, go to Mars, we need to be able to make bigger and bigger spacecraft and bigger space stations, and we need to be able to make them when we get there, as opposed to making them on Earth and launching them into space. So that's kind of the overview of that mission. One of the other missions that we work on is something called the Robotic Refueling mission. And if you've ever seen a toy board that you give a toddler that has a bunch of little buttons and squeakers and spinny things and things that make little babies and toddlers light up and have some fun, this is essentially the robotic version of that. The point of those things is to teach small children how to pick things up and how to interact with things and colors and cause and effect and all kinds of things. And so in order to test out all the pieces for a robot, we do the same thing. If you look at this box, it has all kinds of little ports on it. It has a bunch of markers that we can look at with the robot. It has a bunch of hoses that we can pick up. And so all of those things that you just saw in those animations that we're going to do, we can test out first. And this box launches to the International Space Station. It is actually already on the International Space Station. You can see this picture here of an astronaut taking that box that you just saw and attaching it to the outside of the International Space Station. And you can also see in this, the arm, you can see where it says Canada, that's the Canada arm that Zakiya was talking about. And once we have that on the International Space Station, we can then use that Canada arm to grab some of our test tools and actually interact with the box that you see behind you. And we can test out all of the operations that we need in order to do the robotic refueling mission. Matt, you want to talk a bit about the mission control side of Goddard, I guess?
Sure. So yeah, this is, I think, our mission control center at Goddard, where we've monitored and run a lot of those robotic tests with RRM, like Billy was just talking about. At Goddard, we specialize in basically satellite servicing, in astrophysics, and in earth science. So we have control centers there for a lot of the satellites that do those things, like the Hubble Space Telescope. We have a control room for that does a lot of those, a lot of the images of faraway galaxies and other stars within our galaxy. We have a lot of control rooms for spacecraft that monitor the sun and spacecraft that monitor the Earth. So basically, each control room, when a satellite's normally operating, you may just have like 1 or 2 people there watching over it and making sure that it's, you know, doing everything as expected, and maybe a couple times a day receiving data back from the satellite or sending commands up to it if you want to change what it's doing. But if there's something more complicated going on, say if the satellite is being serviced, or maybe if it's just launched, or if you're troubleshooting a problem, you have a larger team of people, usually that specialize in different parts of the system. So you'll have sort of a flight director that manages and coordinates this whole team. You'll have a propulsion officer that looks at the the engines on the spacecraft, especially when there's any maneuvers going on. Sometimes they may be assisted by a flight dynamics officer that looks at the orbit of the spacecraft and how that changes when you do a maneuver. And then you have people monitoring the electrical power systems, all the computer systems on the satellite. In our case, robotics officer monitoring any motions that the robots are doing on board the spacecraft. And then additionally, some other people, so on and so forth. So basically, you can have all of these people looking at all of those different systems I was talking about earlier that make up a satellite, and make sure that when you're doing these complicated operations, all of those are operating as expected. And then if anything does go wrong, you have all these people that are each experts, and they're part of the satellite in the same room to troubleshoot that and work out a solution as quickly and efficiently as possible.
So it was a good segue there, Matt. Speaking of troubleshooting and working out a solution, this is our test facility at Goddard that we do a bunch of this development and testing work in. And I'll walk through the various pieces, but basically this is the view from above. And this is divided into a bunch of different robotic work cells. And you can see these white robotic arms on the left and the right end of the room. These are like the industrial arms that I talked about before. And you can see in the middle, we've got some flight prototype hardware. And I'll show you a close-up of that one. So this is the prototype of the flight robotic arm that is going to actually fly in space and service the satellites that we're talking about. And you saw this in the video. It has a shoulder down here, just like your arm has a shoulder. It has an elbow here, just like your elbow. And it has a wrist up here, just like your wrist. And so it's really designed very much to work and act and move a lot like your arm. But it is about 4 or 5 times the size of your arm, at least, so that it can pick up much, much bigger objects. It actually, if you look at it though, compared to the white robotic arms that you see in the background, it is much smaller. And the reason for that is because there is no gravity in space. You're in microgravity. And so the arm doesn't need to be nearly as big and beefy as the robotic arms on the ground do to be able to move the big, heavy objects. Here's another picture of one of our test setups. You can see that same robotic arm is mounted to what we call a prototype mock-up. And essentially what that means is it looks kind of like the spacecraft that we're going to be sending up, but it's much simpler and it's just for testing purposes. And you can see it grabbing another spacecraft over here. And this spacecraft is actually on top of another robotic platform that we can use to simulate the motion of the spacecraft in space. And so we can do this by essentially then we're pretending that we're in space. We've got all the lights turned off. You can see this is actually in that room that you saw, but it looks an awful lot like it could be in space. And so that's how we prepare for doing all the operations in space, is by basically pretending and practicing on the ground first. And then once we send the robot into space, we can do all of those maneuvers. So here's another view of that same test where you can just see it moving around. And this is the robot that was hidden in that last picture that is moving the spacecraft mock-up so that it looks like a real spacecraft. Matt, do you want to talk at all about West Virginia?
Sure, I'll start, although you probably know more about it than I do, honestly. So we have an additional team out at West Virginia that does some additional research for us for very new technologies that are, well, I say, the idea is they're sort of newer technologies that may be further away from flying. But that being said, a lot of the technologies they've developed have been incorporated into our system for flight on this mission, as well as on the robotic refueling mission that's on the space station right now. So they have here, what you see is basically a big air hockey table that this robot arm, which is, I think it either did fly on the space shuttle or is very closely related to the ones that did. So it has to be on this table because, like Billy said, with the robot that we're working on right now for our mission, it is designed to not have to support its own weight against gravity, but it can, if you put it horizontally, you can move on this platform and you can do some, sort of assembly work or work servicing larger satellites that you may, with an arm like this, and test out, new tools, new vision systems for the robot to identify where it is along a spacecraft like that. I don't know, Billy, if you have anything else to add about
No, I think that was a good summary. I was gonna just kind of give another view of some of the industrial robots that we have in the test facility, both at Goddard and at West Virginia. So you can see here, the one that I showed before was the prototype flight arm. This one is the kind that you'd find on a factory floor. If you went to a car factory where they're going to put together automobiles, you would see a very similar kind of robotic arm. And the reason that we use these is because, like I said, they're much more powerful on Earth. They're also a lot more cost effective to use for testing before we put it on the flight prototype robotic arm, of which there's only one. So we want to do a bunch of testing with the industrial arms first, and then we put it on the very valuable flight hardware that we're going to send into space. So here's another view of that. This is another work cell in that room where we have this time a different mock-up of the satellite that we're going to go service. And this one is designed, whereas the other one was designed to practice reaching out and grabbing the satellite. This one's designed to practice all of the things that we need to do to refuel the satellite. So we can actually go right down here in the bottom left corner of this spacecraft, and we can pretend that it's all sealed up, and just like we'd find it in space, we can come in here with our cutter and cut open the protective covering and then get in at the valves, and then we can flow pretend fuel. We will usually use some sort of water or alcohol that has the same properties as the fuel, but is a lot safer for us to use in the lab. And then that way we can practice, again, the entire sequence on the ground before we do it in space. So that's kind of an overview of our facility. So Dorothy and Amber, if you've got more questions, we're happy to answer them.
Hi, I actually have one here on Facebook. Katie would like to know, why would NASA have robots do a job that an astronaut can do?
So there's a number of reasons, and I think that it's important to emphasize that there are jobs that are good for people, jobs that are good for robots, and jobs that are good for both. And I don't think that it should ever be looked at as the robot is replacing the astronaut. One of the reasons that we use robots is because we're actually doing jobs that astronauts can't really do easily. For the most part, there's only a limited number of places that we can easily send an astronaut. Right now, the International Space Station is the easiest place to send astronauts. We, of course, are working on rockets to send astronauts back to the moon on a more regular basis than we have done in any time in recent history. But the satellites that we're looking at servicing are in orbits that are very, very difficult for astronauts to get to from the International Space Station. Due to the way that orbital mechanics and gravity work, the International Space Station orbits in one direction, and these satellites orbit in a completely different direction, and at a much higher altitude, so more miles above the surface of the Earth than the International Space Station. So therefore, it's much easier for us to send robots to these satellites because the people can't get there. When you're near the International Space Station, if you noticed the picture that I showed before of the astronaut that was putting the box on the International Space Station, that's an astronaut and a robot working together. So when we're somewhere that is easy enough for astronauts to get to, very often we will still use robots because it makes the astronaut's job easier.
Great answer. And then I have one more question here that just came in. Thomas would like to know, what is a big challenge you have had to overcome recently?
I think that, I don't know, I think we both can answer this one. For me, one of the biggest challenges recently has been transitioning to working from home, trying to do all of this stuff remotely. As you can imagine, with a team of people the size that we have and the amount of hardware that we have, there's a lot of times where you have a bunch of people in a room trying to build something. And with pandemic, with all of the social distancing in place, that becomes a lot harder to do. And so we've gone to most of the team works remotely, and only the people that absolutely need to be working on hardware go on site on any given day. So for the most part, most of my week is at home. Every once in a while, I get a week where I'm on site once or twice to try and work out some hardware issues. And then we go back to some of the design work and some of the software work that can be done remotely. So Matt, do you have something else?
Yeah,
that
I
you want
couldn't
to
agree more with that. And I think I would just to add, there's a little more specificity, sort of keeping everyone on the same page when you're not, in the same room working together, maybe not physically around the conference room. And sort of if you have like a picture of what you want to do or a solution in your head, getting that into everyone else's head. So that's definitely been something, adapting to doing that in a virtual environment, largely through PowerPoint. You definitely use a lot of PowerPoint for any work that we do, especially we do sort of systems engineering, which is kind of being the, understanding a bit of everything and sort of being the go-between or like the mediator that makes sure that all the different groups have all the information that they need from each other to make sure that they're all building the spacecraft. They're all building the same spacecraft. So keeping everyone on the same page like that without being in the same room is something that has, taken time to adapt to.
Well, great. We do have a number of questions in Zoom, and one of them is from Jackson, and it's about the box that we see in the photo. And he's saying, why does the box have to be on the ISS?
The main reason that we want to put it on the International Space Station is so that we are in space when we do these test procedures. So you saw the industrial arms that we used on the ground. We've worked out all of the procedures on the ground, but there is a lot of things that change between doing it in the lab on the ground and doing it in space. One of these things is probably the most commonly thought of thing is that you're in microgravity. The robot actually does respond differently in gravity versus in microgravity. And sometimes it's in things that aren't necessarily evident until you really start poking at it and you realize how much influence gravity has. For instance, removing that protective covering on the ground when we do it, all of the things that we cut off fall to the ground. They fall down, they end up, underneath the robot on the floor, and you come through, you sweep them up, and that's it. But in space, they won't fall down. They will actually just kind of stay there, and they will start to float away and get in the way. So one of the things is we had to come up with a way to make sure that we removed it without detaching it so that it stayed where we wanted it to stay. And testing those kinds of features in space where we're actually in microgravity is a lot easier than on the ground. One of the other things, and this is not necessarily always understood until you start to really dig into the problem, is that with no air in space, some of these things actually react very differently. So whereas when you touch a material on the ground, it might move a little bit, but not all that much. Without the air to hold it in place, it actually can move very differently in space. So we want to test out how these things work both without gravity and without air.
That's excellent. And I want to let our participants know that even though we were thinking about an hour, we have a number of questions here, and we're just going to go through them and answer as many as we can. So if you want to stay on, we're going to be here and answering questions. And the next one is from Lucia saying, we love robots, and it's actually from Dylan, who is 8, and Owen, who is 5, and they're from Bethesda. Are you working on a new robot right now?
Matt, you want to talk a bit more about the Restore Arm? That's
Sure.
our,
So yeah,
our
this
newest robot.
Yeah, this arm that Billy was showing before is a new robot that is being specifically developed for this mission. It's definitely, takes inspiration from a couple other robots that have flown in space previously. But this one is specifically developed for this mission. Trying to think if there's any additional details that Billy hasn't spoken about already.
They're actually the other new robot that we're developing. I don't have pictures of it, but one of the missions we're working on is getting samples back from Mars, from the Mars rovers. There is a robot arm in that mission that will be able to grab the samples and put them in a nice, neat stowage container so that they can come back to Earth safely. So there's a new robot arm that's being developed there as well.
That's great. Thank you. Connie is asking a question about fuel, and you did speak to a lot of this, but one of her additional questions is, are robotics powered by battery?
Sometimes, I guess I would say the answer is, so the spacecraft does have solar panels that power the robot when we're in sunlight. But usually when you're orbiting the Earth, it depends on what orbit you're in. But a lot of satellites spend about half their time in daylight and half their time in the Earth's shadow and basically in night. So all satellites, based on whatever orbit they're going to be in, they have batteries on board so they can keep operating throughout the night. So in the same way, we can operate off of solar panels when we have daylight, or we can operate the arm off of those batteries at night.
Thank you, Matt. Bruno is asking, and I'm not sure if this is for both libraries and for NASA, but maybe we can both answer it. Do you have any robotics programs for elementary kids?
I don't know if NASA specifically does. Do you know, Billy? I know
that there. Yeah,
Sorry,
I know that there are some things that are NASA sponsored. I will admit that I'm not quite familiar enough with those programs, but there are also different levels of FIRST Robotics. There's FIRST LEGO League, which I believe goes as far down as 6 and 7 year old levels of competition. So you might look into things like the FIRST LEGO League, things like Bot Ball, and other kinds of robotics programs like that.
And I think a lot of elementary schools have robotics programs now, so that you may want to look into if your school or a local school has like a after-school robotics club or something like that.
I also know that there are organizations in the area, and unfortunately, I don't know what ones they are. But our boss's kids went to both robotics camp and coding camp this summer, so you might look into those kinds of programs as well.
And I would encourage you to call your local library to see what they may be offering, because we often have those types of educational organizations come in to do like a robotics camp during the summer in the library as well. Now, Olivia, who's 4 years old, is asking, is it harder to move a robot in a vacuum, parentheses, spaceship, than it is on Earth?
So I think I would say that it is, in terms of like actually moving the robot, it is easier on a spaceship when you're in the vacuum of space. But that's not necessarily because of the vacuum as much as it is because of the lack of gravity. You know, you don't have to constantly be fighting against the whole weight of the robot. You can, you know, kind of give it a push and it'll keep going. But that being said, there are a lot of you know, complications that result if you are operating a robot in space, especially if you're operating it remotely. If you're operating it from like a mission control center on the ground, one of the biggest issues is there's a time delay that you know, may be as much as a couple of seconds. So if you can, you know, imagine if you're like trying to, you know, drive a robot with a joystick or something, and it doesn't start moving until 3 or 4 seconds after you know, push the joystick in a direction, and you're near like another satellite that you want to repair. You have to be very careful and do things very slowly because you don't have a very fast reaction time.
Thank you. Someone is asking, how is the oxygen made on the ISS?
So the ISS actually, for the most part, they don't make it on the ISS. It's shipped up. So if you look at rocket launches, there was one recently that you may have seen in the news that launched from Wallops Flight Center out in Virginia. It was visible from our area. You could look up in the sky and see it. When they send up rocket launches to the International Space Station like that, they're resupplies. And so what that means is that just like, you know, if you went on vacation and you sent somebody a box of souvenirs home, it's the same kind of thing. You load the space capsule with a bunch of supplies. In the case of the International Space Station, those supplies include food, and they include water, and they also include oxygen so that you can keep the air in the space station.
Thank you. That's great. The next question is from Mikey, and the question is, who made the Curiosity? And I'm not sure if the Curiosity is one of your satellites or a spaceship.
Curiosity is the Mars rover that's currently driving around on the surface of Mars.
Great, great.
Curiosity was built by the folks out at NASA's Jet Propulsion Laboratory out in Pasadena, California.
Okay, great. Let's see, Bruno's asking another question. He says that he's 9 years old and he's wondering if he could intern at NASA.
So if you check out the website that I was talking about before, there will be all kinds of opportunities. I don't know exactly what the youngest age that you can do an internship is, but there are definitely other programs like camps and things like that, and some of the interactive activities that are meant for all ages. And Dorothy, like you said, check out the local libraries, and they work with some of the local organizations that can find some of those opportunities for you.
Right, and then those kind of opportunities may eventually lead to an intern when you're old enough.
Absolutely. As you saw our coworker Zakia said, she started as a kid doing bot ball, and eventually that led to an internship at NASA.
Now, Quinny is asking, has NASA created any robots to mine precious metals on asteroids?
So not yet, but one of the missions that I worked on several years ago was actually investigating some of that. So the robot arm that you see here, we had designed a similar robot arm that was going to go to an asteroid, land on an asteroid, and pick up a very, very large boulder off the surface of that asteroid and bring it back so that we could actually study it and figure out what minerals we might be able to mine from it. So while we haven't done that yet, it's definitely something that a lot of people are thinking about, and a lot of people are trying to figure out how we might do it.
Gosh, we may have a space gold rush someday. You never know.
You never know.
Another question is, we have a MIP, but Phil, we are ready to move up. What would you suggest?
I'm sorry, can you, I'm not sure I
It's
followed the question.
MIP, and I'm not sure what that is. Tell you
I'm
what,
not
I'll look
familiar
it up, but we can
Okay.
go on to the next one. So Aiden is asking or kind of verifying that the moon is a satellite, is considered a satellite.
It is technically, yeah. And actually, the first satellite that we launched, that the Earth launched, Sputnik, when it launched, basically all of the newspaper headlines and everything was that humans had created an artificial moon that was now orbiting the Earth. So, yeah, the two are, very closely linked together, and the moon is technically a satellite.
That's great. So a MIP, and I don't know if you'll be able to see this, it is a small, let's see, like a small robot. And let's see if I can show it to you there. So it's one that rolls. So
Let me see what I can find.
okay. And while you're looking, let's see.
Okay. I do know, I didn't know its name, but now I know what you're talking about. So that was one of the, I think at some point somebody was asking about how hard it is to code robots. The MIP, I don't know how it's pronounced, is one of those robots that actually has an app. And so you can load it on your phone, you can load the app, and you can drive the robot around. You can program it to do things that you want to do around your house.
It's great. Now, Ava, age 8, is asking, where do you put your sensors? Where is it best used?
Matt, you want to talk about the force torque sensors and the position sensors and things?
Sure, yeah. So it depends on, how the sensor works and what it's trying to measure. So like Billy was just mentioning, we have what's called the force torque sensor, which is on the end of our arm. And that is basically, the robot, that's sort of how it feels where it is. So it can, sense if it's like pushing up against something the same way that you could on your hand. You could feel if you're like pushing on a wall, the wall pushing back at you. That's what this sensor does for the robot. So basically, we don't want any sort of noise or disturbances from like in the robot to interfere with that. And we want it, our robot is based on a human arm, so we want that to be as close to sort of, if you can think of where the robot's hand would be, as possible. So you have that same sort of feeling of like whatever tool the robot's using, reading the forces that that's experiencing. So because of that, that one is positioned basically where your wrist would be, on the end of the robot arm. Additionally, we have some other sensors that are not on the robot itself, but are sort of on the main body of the spacecraft. A lot of cameras and things like that. And those although we do have cameras on the end of the arm as well, but those you basically want a clear field of view of whatever they're supposed to be looking at. So you place them wherever you can, where they won't have where they'll have an unobstructed view of, say, the satellite that we're servicing.
Great, thank you. Aiden is asking, how far are Voyager 1 and 2?
So those are very far. I forget the exact distance, but I believe it's over 100 times as far from the Earth as the Earth is from the sun, if that makes sense. So, the Earth is so far from the sun that it takes light from the sun 8 minutes to reach the Earth. So if you can imagine, it takes like 800 minutes or something, which is like several hours for signals from Voyager, which travel at the speed of light, to make it back to the Earth. Voyager 1 and 2 are actually on the very outer boundary of our solar system, what's known as the heliopause, where helio is basically the Greek word for the sun. So it's where sort of the effects from the sun pause or like come to an end. It's the sort of outer boundary of our solar system.
Great, thank you. Sarah is asking, are there any online classes that NASA offers?
NASA does all kinds of online and interactive events. The video that we showed you was actually one of those kinds of things. If you go to NASA's YouTube page or go to Satellite Servicing's YouTube page, you can find them. NASA does have a bunch of different groups that do outreach and interactive events as well. Things like this, actually, usually those kinds of things are in partnership with local people, local libraries, local organizations. And there are also a lot of the camps and things that NASA will host have gone online. So there are all kinds of resources out there.
Yeah, just doing a quick search, there's the NASA at Home, which is, I believe, where that
Yes.
video is located. And looks like a lot of great information there. Okay, Molly is is asking for her son, Connor, who's 4 years old. Connor is wondering, what is the best thing he can do now to prepare to be an astronaut when he grows up?
Ask questions. Be curious. Never take an answer for granted. If you want to know something and you ask somebody and they don't know, go ask somebody else or go look it up. Go figure it out. Go experiment. Be curious. That's the best advice that I can give. I personally actually have applied to be an astronaut 3 times now. It's very, very hard. But mostly what they look for are people that have a thirst for knowledge and have good ability to work with a team of people. So that's why I say, go ask questions and go listen to what other people have to say so that you can learn something new every day.
It's great. That's great for all kinds of jobs and careers too. Let's see. So we're getting a couple of questions about internships for children again, and mentioning the 3-day camps, virtual camps, and so on. But just wondering if to take an entire school year program, and I'm thinking there probably are some schools that really focus in at least on STEM, maybe
Yes,
as
absolutely.
their yeah. Let's see what else we have here. Okay, is coding vital in doing robotics? Do you do coding?
Yes.
As I said, I would say it is like we could not do robotics without it. But we have people that have all sorts of different skills on our team. So if you're into coding, that is a great way to get into robotics. But if you're not, that doesn't mean that like you shouldn't consider robotics. There's tons of roles we need people doing mechanical work, electrical work. There's lots of things in addition to coding as well.
That's great. Let's see. Jennifer is asking about the fuel. Is it fossil fuels that's used?
So some are, some are not. The rockets that use hydrogen and oxygen, those are not fossil fuels. Those are usually taken out of water and out of the atmosphere by special machinery that can basically pull those elements out of the water and the oxygen in the atmosphere. The hypergolic fuels that I was talking about are not fossil fuels. Those are specially manufactured. So those don't actually occur naturally. They're man-made. And usually they're man-made from a bunch of different chemicals, some of which might come from fossil fuels. The methane and the RP-8 rockets that I was talking about, which do use more traditional gasoline type fuel, those do come from fossil fuels typically.
Sure. Okay, Zahara and Tele are asking, they're just saying amazing to the presentation, but how did you path your way as a child into the future to have a career into NASA? Like, what excited you as kids?
You want to take this one first, Matt?
Sure. So yeah, I've just always been really, really interested in spaceflight since probably when I was like, as long as I can remember, so since like, 3 or 4, if not earlier. And I started out, as has been suggested, I think multiple times tonight, going to, it was called the Young Astronauts Program at the local science museum. And, programs like that at science museums and local schools, I started out with that and, learned as much as I could about things that are going on in space. And then, in school, focusing on math and science classes. That definitely is helpful for the engineering side. Although, we have people on our team that are not engineers as well. Like, I know Katie, who helped organize this, does basically exclusively communications and public outreach, and you can be in that field and also get into spaceflight. But in terms of my path, it was really doing that math and science throughout grade school, and then in university doing engineering. And really, we need all sorts of engineering for any sort of space mission, but especially aerospace engineering, mechanical engineering, electrical engineering. I'd say those are the biggest ones, but there's like so many different skills that we need in space. Like, we could probably find someone at NASA that does just about any profession, and in doing so contributes to the space program.
Yeah, I think my path is very, very similar. I also did Young Astronauts in middle school. So that's a good reminder of there's a club and activity that you could probably get involved in elementary and middle school. I also went to space camp multiple times. There are a bunch of different levels of space camp for all ages. There's elementary school, there's that you can go with your parents, with your teachers. There's middle school, there's high school levels, and there's even college level camps that you can go to. So things like that just give you the opportunity to be exposed to new and interesting things. And also I was very interested in the science side of things in school. So I loved science classes and things like that. And lots of Legos. I had lots of Legos as a kid. I still have lots of Legos. There's actually a Lego Saturn V sitting on my desk right next to me.
Yeah, definitely second to lots of Legos. And I have my Lego Saturn V sitting just to the right of my desk.
It's great. Well, we're going to shift gears a little bit. Is SOHO still orbiting the sun? And that's from Aiden.
I
think so.
Sorry, what did you say, Billy?
I think I was about to say the same thing you were. So go ahead.
Yeah, I believe it is still orbiting the sun. It's actually in a very special orbit called a Lagrange or libration orbit, which is where it is sort of, you go to the edge of the Earth's gravitational field, right where the Earth and the sun's gravitational field and some other forces in orbit balance each other out. So SOHO stays, basically pointed at the sun, but also close to the Earth. So you have a constant line of communication with the Earth. And yeah, I believe it is still at that point.
Great, thank you. Here's another different sort of question. Has COVID-19 set you back at all? I know you talked a little bit about change of work and needing to set up your home to be
Yes.
as useful.
Yeah, there's definitely been some adjustments, and I think that it was definitely an adaptation to go to working from home when you're used to seeing all the people on your team on a daily basis, and you can walk up to their desks or catch them in the hallway and ask questions. It definitely slowed things down a little bit at first. There's some learning curve to that. Also, there is a decent amount of what we do that is hardware related, that you have to actually be there in person and working with a piece of equipment or electronics or a robot or something that we had to put on hold a little bit. And so there have been some delays, but I think we've managed to do a pretty good job of adapting, of adjusting. And so we're continuing to push forward towards our launch date and get all of the tests and things done that we need to.
Excellent.
Yeah, we're sort of like reorganizing how we're doing things. So we do as much of the planning as we can now. So whenever we can all be back in person, we can get through, all of that, physical hands-on work with the robots done as quickly as possible.
Excellent. This is from 13-year-old Alec, and it's referring to the photo that you had of your floor lab and asking, what is the tape on the floor in your lab used for?
Lots of things.
Yeah, we have a couple different things that it does. One of the big ones is that we sort of mark out the maximum reach of each robot. So you can probably see, like in my background behind me, that we have a fence around each robot. And that's basically to keep people out when the robots are operating. Just, that these are sort of very strong and powerful robots. So just for, safety purposes, it's good to know how far exactly the robots can reach. I think that's probably the biggest thing. There's some other specific things for anyone that's done theater. You'll have like markings on the stage taped down for where you're supposed to stand at certain points. So we similarly have hardware that we'll sometimes place inside of one of these workspaces with a robot, like maybe some cameras or some other equipment. So just to make sure that we put that back at the same position every time. And then we have some additional tape markings outside of the workspace, just sort of to make clear where walkways are, just so people can move around the room without any difficulty, and make sure that no big hardware gets sort of put in the way, obstructing any walkway or anything like that.
Thank you. That was a great question. Jackson is asking, it was in the picture of the ISS, what were the modules that were shown?
So the ISS was put together as a bunch of individual pieces that were sent up both on rockets as well as on the space shuttle. And they were assembled in orbit. So the astronauts basically put all of those pieces together. So each module has a different purpose. One of them is where the crew bunks are. So that's the habitation module. That's where the astronauts live and sleep. There are different science modules where the astronauts do various experiments. There are storage modules that are basically the closets for all of those supplies that get sent up. And then there are docking modules, which is where the spacecraft dock to and can unload.
Great, thank you. Let's see. Nazar is asking, how expensive are robots?
Robots are all kinds of different cost levels. So depending on, some of those little robots like we were talking about earlier that you can get in your home, some of those are cheap enough that you could collect up a few a few of your allowance and go to the store and buy it. The ones that you see behind us, and I apologize, it seems like my video is not showing, but that you can see behind Matt. Those are much more expensive. Those are, you have to basically be a company to be able to buy those because they're large, they're expensive, they're very complicated. The ones that we're building, the flight robot that we showed earlier, that one is very expensive because it's one of a kind, and there are a lot of people working very hard to make it a very special robot that can fly in space. So as you can imagine, the more complex, the more specialized the robot, the more expensive they get, the more it costs to put them together.
Great, thank you. 7-year-old Abby is asking, how long does it take to build a robot?
I'd say it depends on the robot. To actually build it, if you have like one of these industrial robots, like this sort of blue and white one that you can see behind me, those I think are basically built on an assembly line, probably built by other robots very similar to them. So physically building those, that could be like, a matter of days or less. For our, space robots, because like Billy said, that's one of a kind and we're kind of learning how to do it as we do it, that takes much longer. That can take several years to build.
Thank you. Let's see, Taylor was asking previously, not so much about how the oxygen is made in space, but how do you filter the air to breathe and grow plants? And do robots play a role in that?
I think that robots do play a role in some of the maintenance of the space station in some really interesting ways. The oxygen on the space station, the air is filtered just like it's filtered in your air conditioning system in your house. If you go look at your air conditioner, there is a filter in there, and that filter is made of a special porous material that will let air through but doesn't let things that you don't want through. So like dust and germs and things like that. They're much fancier, much more high quality filters than what you put in your air conditioning system, but they do the same thing. But one of the interesting things about the International Space Station, they actually have a special tool on the International Space Station called a robotic leak locator that our group actually built and sent to the International Space Station a couple years ago. And they can put that on the end of the robot, and they can identify where there are leaks in the International Space Station to help prevent the air from leaking out so that they keep the best quality, cleanest air possible.
That's great. 4-year-old Connor is also asking and wondering if you can make robots into spaceships.
I think so. So you mean like, I guess if you're talking about like a robot that has its own spaceship, that's kind of what this OSAM-1 mission that we're working on is. So that is a entirely robotic mission. There's no people on it, but it has 3 robots on it. Two of the ones that Billy had a picture of before that we're developing, as well as a additional one that is assembling that antenna that's on it. So you can, you can basically combine a robot and a spaceship into a single object, or into a robot that can move around.
Great. Let's see. Why is Pluto not a planet anymore, or is it a planet again?
So one of the things that is fascinating is we are always learning new things about space. And one of the things that most people don't really realize is that Pluto is not the first thing to have been thought to be a planet and then determined not to be a planet. For thousands and thousands of years, we only knew about the planets that we could see by looking up at the sky, and those are Mercury, Venus, Mars, Jupiter, and Saturn. And then when we got telescopes, we could see further, and we could see all kinds of things, and we could see the asteroid belt. We could see a very large asteroid called Ceres, which when it was discovered, everybody called it a planet. And then the more we learn about the universe, the more we learn about the things around us, the more we realize that there's all kinds of different things out there. And so the more we realize that, we started to realize a planet is actually something very specific. And one of the key pieces of being a planet is that it has enough gravity to have basically emptied its yard. Nobody else around. It has nobody else that it's going to crash into. And Pluto actually hasn't done that. Pluto crosses the orbit of Neptune, and Pluto also has a bunch of asteroids and debris and space junk circling around near it. And so we realized we thought Pluto was a planet, but it's actually not. And so we reclassified it. That doesn't mean that we're not going to find other planets, but it just means that we realized Pluto is something slightly different than what we thought it was because we learned more about it.
It also doesn't mean that it's any less interesting because it's not a planet. Like I say, a lot of the mission concepts that I've worked on are going to asteroids or other small bodies, and Pluto is what's known as a dwarf planet, which is sort of sort of a hybrid in a lot of ways, or somewhere between a planet and like an asteroid or comet. So it's still just as interesting, potentially even more interesting, in the sense that we have, we've sent missions to all of the planets in the solar system at this point, but there's still lots that, we know a lot more about most of the planets than we do about asteroids and comets in a lot of ways.
Interesting. Do all satellites have the gold covers? And this is from Aiden.
So not all satellites are gold, but all satellites do have some sort of covering like that, because when you are in space, the sun is actually very, very hot. And most people think of space as being very cold. But when you go walk out your front door on a sunny day, you can feel the warmth of the sun. And the reason that you can feel that is because it is shining directly on you, but it actually is shining through all of the atmosphere. So the air and the clouds and everything cover up some of that sunlight. If that atmosphere wasn't there, you would get all of the warmth of the sun directly on you. So that covering, that gold covering, is actually protecting the satellite from getting too hot when it's in the sunlight. There's other colors, as you can see behind Matt, there's a couple different colors of things behind him. Those are all different types of that covering. And it just protects the satellite from getting too hot and from being damaged in space.
These are such great questions. I'm learning so much. Let's see. We have another one. What are a few key skill sets or disciplines needed in making robots? You've talked a little bit about it, but just maybe a few thoughts on that, skill sets.
So I'd say, yeah, like I said, programming is definitely a really big one. Mechanical design, so not just mechanical engineering, but also actual, fabrication or like making mechanical systems is really, really important. Electronics are definitely really, really important, and the mechanisms and electronics really come together when you're making the motors that drive that drive the robots. Yeah, I guess those are the really big ones that I can think of. I don't know if you have any more to add, Billy.
I think that there's a lot of math and a lot of science of materials and mechanics and things like that go into it. But one of the things that's actually really important is problem solving, is critical thinking, because robots are complex systems. So there's always going to be something that doesn't quite work the way you want it to, and you have to figure out why. And so working with your team of people to figure out why is really a good skill to have in working with something as complex as a robot.
Great, thank you. We're just about finished. We have a few more. And let me just say, somebody's asking when is the next event, and it is for the Maryland STEM Festival, October 21st, which is next Wednesday at 4 o'clock. So if you go to the Maryland STEM Festival website, you can find that event, and it is going to be a conversation with astronaut Ricky Arnold. So we're real excited about that. So let's just finish up here. Do you have any good book recommendations about robotic programs for those without a technical background, especially ones for a motivated teen? And that was from Melinda.
That's a good question. I don't know that I have one readily available off the tip of my tongue, but I can certainly put together a few things, and Dorothy, I can send them to you if you want to send out the information.
I will. I'll be sending out the recording early next week, so once I get yours, I can send out any of your book recommendations. And
yeah, sure. Matt, do you know of any off the top of your head?
I'm trying to think if there's any specifically for a teen. I know I'll say that something that is like maybe surprisingly, maybe not really good tool is Wikipedia. If you just, start looking at, any robot page that you can think of on there, and then just like follow any links for anything you're not familiar with, that's a really, really good way to learn a lot, learn a very wide amount about any area. And especially I've looked through some of the robotics pages on Wikipedia, and a lot of them are really, really good to get, I think, like the sort of knowledge that you're looking for.
because there's a lot of people focused in on a topic, so they're listing why they're posting that information, listing the references, the resources, and other links to kind of expand beyond just that basic information.
That's right. Yeah, and any topic or any like other robot or something that's referenced by where you start out, it can take you in like all sorts of different directions to learn a lot about the field.
That's great. Thank you. Let's see. Quinny is asking, I think this is our last question here. I have read that there have been planets that are more habitable than Earth. How can a planet be more habitable than Earth, I guess is really the question.
That's really something that scientists are trying to understand. It's only been in the past few years that scientists have been able to really have the telescopes and the techniques that they need to find all of these new planets outside of our solar system. So they're called exoplanets because exo means outside of. And so all of these new exoplanets that we're discovering have all kinds of qualities that are very different or very similar to Earth all over the place. And we've learned that there are more kinds of planets than we could have possibly imagined. I'm sure that when they say it's more habitable than Earth, what it actually means is that it probably has a little bit less of a temperature swing. So if there are definitely places on Earth that get far too hot for people and far too cold for people. The oxygen in the atmosphere is probably a little bit different of a ratio. So maybe that's a good thing for people being able to breathe. And it might have some tamer weather, for instance, or less disasters, things like earthquakes and hurricanes and things like that. So if we look at the Earth as a planet, it's a pretty violent place to be sometimes because of all of these kinds of things. But people are actually really adaptable, and over thousands of years have gotten really good at living here. So that's not to say that there aren't other places that might be a little bit easier to live.
Great answer. Thank you. That was very interesting. Amber, I think there's another question from Facebook.
Yes, I have one last question from Facebook. Denny would like to know, what is the difference between an asteroid and space junk?
Nothing, really. An asteroid is what's left over from the formation of the solar system. So depending on how you look at it, the saying, one person's treasure is another person's junk. The asteroid is just what's left over from formation of the solar system that didn't become a planet. And so it's just floating around out there, just a rock in space.
Excellent. We have Austin saying thanks for the information. We have others saying how grateful they are. And thank you for taking the time with us today. And I think Amber and I want to echo that. So thank you very much.
Yes, thank you.
Matt and Billy, this was fantastic.
I'm
Yeah,
very
thank you
happy
for the
that I
invitation.
could be here. Yeah, thank you.
Well, I guess I'm going to go ahead and just put in this last screen, Amber, and then why don't we close it on out? And here we go. And that way we are thanking our sponsors once again, NASA and the Maryland STEM Festival. So thanks everybody for joining us tonight.